And the structure on the right side. So the argumentation structure is actually a tree structure which starts with a major claim, and below that you have here the different arguments which are constructed by claims, premises, and the argumentative relations between those components. I will not go here into details, but I want to emphasize two important properties of argumentation structures. The first is that those argumentative relations can be implicit. That means they are not indicated by any discourse connectives, and therefore it's a hard task to identify those. Another property is that the relations can also hold between non-adjacent text units. So for sure there's some related work in the area of argumentation mining. There's some work which deals with separating argumentative from non-argumentative text units. There's work which aims at classifying argument components in, for example, claims or premises. And there's some very limited work about identifying argumentation structures. So there's one approach introduced from Morales-Palau, which aims at identifying those structures in legal documents. And yeah, this is actually a limitation, because in legal documents you usually have a standardized form of argumentation, and the discourse connectives are also used very properly, because those documents are usually written by professional lawyers. And yeah, therefore we cannot use those approaches to more general types of text, or text where the discourse markers are or may be used not so good as in those kind of documents. Another related research area is discourse analysis. You all know the approaches based on the rhetorical structure theory or the Penn discourse tree bank. The problem here is that most of, or both approaches do not include a distinct set of argumentative relations. For sure there are relations which are related to argumentation, but we do not have this particular support or tag relation. And the other problem is that the current discourse parsers do only consider relations between adjacent text units. Therefore, we cannot use them directly for identifying argumentative relations or argumentation structures. So in our approach is actually split into two steps. First, we identify argument components, and we separate argumentative from non-argumentative text units and identify the types of the components in the first step, and we consider this task as a multi-class classification task. And in the second step, we identify the argumentative relations by classifying a pair of argument components as either support or non-support. And I have to mention here that we do not deal in this work with the separation of the text So we assume that the segmentation of the argument components is given by the gold standard. As data for our work, we used an argument structure annotated corpus that we have compiled in previous work. It contains 90 persuasive essays, which we collected from an essay forum, and it is annotated with the scheme that you have seen on the previous slides. In total, it contains about 1,700 sentences and 35,000 tokens, and we were able to annotate this corpus with substantial inter-annotator agreement with 3 annotators. So I will now describe the first task. As I said before, we consider the first task of identifying the argument components as a multi-class classification task, where we classify a text unit as either major claim, premise, or none. We consider each sentence which does not contain any argument component as class none. And I have to mention here that this is not an exclusive feature for this group. There are also 30% of other sentences or argument components which cover a complete sentence. Here you can see the class distribution. Each essay includes exactly 1 major claim. We have 429 claims, 1,033 premises, and 327 non-argument components in this corpus. For pre-processing, we used some analysis engines from the DK-Pro framework and a text classification tool which is called DK-Pro TC. This tool also includes some classifiers from the WEKA framework. We split our data into an 80% training set and a 20% test set and identified the best performing system by using tenfold cross-validation on the training set only. So here you can see the features. Because of temporal reasons, I cannot describe the features in full detail here, but you can find the details in the paper. So we used structural features, lexical features, syntactic features, some indicators which we collected from the Penn Discourse treebank manual. We selected there some connectives which are argumentative or might indicate some argumentative argumentative components, and we also included some contextual features for that task. First, we compared several classifiers and found that an SVM performs best if we use the 100 top-ranked features and we use information gain for selecting the features. We experimented with several classifiers, namely SVM, decision trees, random forest, and naive bias, and found that all of those classifiers significantly outperform a majority baseline. Our model achieved an accuracy of .773 and a macro F1 measure of .726. And we compared that also to human performance and found that our model achieves 88.1% of human performance, and it performs very well for distinguishing argumentative and non-argumentative text units. And it seems that the major problem here is to identify the claim or to distinguish between claims and premises. So we also identified the different features that we have defined for that task, and found that the structural features indeed perform very well for that task, and in particular for distinguishing between argumentative and non-argumentative text units. Lexical features performed also quite good, as well as syntactic features. Interestingly, the indicators did not perform well for separating argumentative and non-argumentative text units. One reason for that could be that those indicators are often ambiguous. For example, the connector since often signals a reason, but it can also signal a temporal relation. That might be one reason why those indicators are not good for that task. And we also found that the contextual features do not perform well when we use them without other features. However, they increase the accuracy by 0.7%, but this is not a significant difference here. We also conducted an error analysis for that task and found that the highest confusion was between claims and premises. 193 claims are misclassified as premises. And one reason for that could be that the claims are often similar to premises because they are given as support for the major claim. Therefore, they use similar discourse connectives. And the second reason is that claims do not include or may not include any indicators at all. Here you can see an example Competition helps in improvement and evolution, and it's even hard for humans to distinguish without some sophisticated contextual information if that sentence is a claim or a premise. So a possible solution for improving the results might be to include more sophisticated contextual features. So I switch now to the second task, where we aim to classify or identify the argumentative relations between the components. And as said before, we classify a pair as either support or non-support. In this work, we did not consider the attack relations because we had too few of them in our corpus. There were only 161 attack relations. We extracted for that task each possible pair from each paragraph, which resulted in this class distribution here. It's a highly skewed class distribution, so we have 15.6% support and 84.4% non-support false instances for that task. We used the same pre-processing tools and also split the data into an 80% and 20% test set. As features for that task, we used structural features, lexical features, in particular word pairs, which have been proven to perform well for that task. We used the same syntactic features as in the previous step, namely production rules, which were proposed by previous work, and the same list of indicators. And we also integrated the predicted type from the first experiment as features. In a comparison of several classifiers, we found that, again, an SVM performs best for that task, and that all other classifiers except the decision tree significantly outperformed the majority baseline. Our model achieved an accuracy of 0.863, which is only slightly above the majority baseline. However, since we have a high class imbalance in that task, the macro F1 measure is actually the better measure, and there we achieved an accuracy of 0.722, which is far above the majority baseline. Compared to the human performance, we achieved in that task an accuracy of 90.5%. So let's take a look at the different features that we defined. Interestingly, the structural features did not perform well for that task, and however, the performance decreases significantly if we remove them from the entire feature set. So it seems that they indeed help for that task. However, if we use only structural features, it is not helpful for that task. Lexical features perform best. Syntactic features also contributed to that task, as well as the indicators. Interestingly, the predicted types from our first experiment did not help at all for identifying argumentative relations. Although those features exhibit the highest information gain in each experiment that we conducted. And unfortunately, this difference is also not significant when we omit those features from the entire feature set. I will comment on that later. So we conducted a manual error analysis and investigated false positives and false negatives, and found that indeed many of the false positives could be prevented with better results from the first task. So for example, we found 32 relations from a claim to a premise and 18 relations from a claim to another claim, which are actually not allowed in our annotation scheme. And having better information from the first task might help to prevent those errors. The bigger problem here in this experiment is in the false negative set. There, the errors are frequently due to missing contextual information and also unresolved co-references. So here you can see an example which was not identified as a support relation. The claim here is exercising improved self-esteem and confidence, which is supported by it helps relieve tension and stress. And it might help to resolve this co-reference here in the premise with exercising to improve those results. So now I will briefly discuss the approach that I presented here. So for sure, both tasks are somehow related. And we found that sharing mutual information between the two tasks indeed helps and leads to improvements. So if we include, for example, in the component classification, the the number of incoming and outcoming relations from our gold standard, we could nearly achieve human performance. And the other way around, if we have correct type information of the components, we were also able to improve the relation identification, and also were able to nearly achieve human performance. So we assume if we are able to improve one of those tasks, we can also improve the other one. We found also that the major challenge is the distinction between claims and premises. And we found that structural features perform best for that task. However, those features might be unique to persuasive essays. For example, we found that those structural features are very helpful also for separating argumentative and non-argumentative text units. For example, at the beginning of such an essay, the author starts to introducing the topic and so on, and those sentences are usually not argumentative. And it's still an open question if there are some general structural features of argumentative discourse which generalize over other text genres, actually. We also found that the discourse markers yield low accuracies compared to previous work. So I mentioned that approach for Morales-Palau, that they used a context-free grammar approach, which relies heavily on discourse markers. They were able to achieve an accuracy of an F measure of 0.673 in legal documents, and in our results, using only discourse markers resulted in F measure of 0.265. So this result indicates in some way that our initial assumption is right, and that we can indeed not rely only on discourse markers, and that we cannot use such rule-based approaches for more general types of documents. And it also shows that indicators are indeed misleadingly used in student text, and that there is really a need for argumentative writing support for guiding students and helping them to improve the argumentation and the structure. So to summarize my work, I will briefly outline the main contributions. So I have presented an approach for identifying argumentative discourse structures in persuasive essays. This approach is also able to identify implicit argumentative structures, and it's a first step towards computational argument analysis in the educational domain. The performance of the approach was quite promising, however, there's still some room for improvement. We achieved an accuracy or 88.1% of human performance for identifying the argument components, and 90.5% of the human performance for identifying argumentative relations. For future work, we plan to investigate the segmentation of the argument components and to extend our studies to larger corpora. In addition, it would be very interesting to integrate those classifiers into writing environments and to find out if those systems can really support students in improving the quality of argumentation skills, and if it has really an effect for the argumentation skills of students. Thanks a lot for your attention, and now I'm available for any questions.
Okay, thanks. If you have any questions?
Thank you. Very interesting paper. Especially, I'm interested in the difference between the performance of the discourse markers on the legal text and in this with the student writing, which once you present it seems very commonsensical that students would have difficulty with that aspect of their writing. So have you looked at, in a sense, whether you could generate appropriate discourse markers that you could suggest to students? That seems like a natural thing to do, but I wonder how much analysis you've done on it, and if you could say something about it.
So until now, we have not considered that task, but this is actually on our research agenda. So we are currently doing some studies with students and in the area of argumentative writing, and with particular focus on those discourse markers. And yeah, this is actually all I can say about that. We are planning that, and this will, so I assume if we have the argumentation structure, and we are able to identify the argumentation structure precisely in those student writings, it might be possible to as you suggested, to also recommend actually better structures or better comprehensible argumentation structures, including also recommendations for discourse markers, yes. So this is actually future work.
Yeah, I look forward to seeing your future work in this area. You probably could get a lot of mileage out of just pointing out something that where they've failed to make it very clear without even suggesting to them what they should do to make it clear.
Exactly. Thanks
just draw their attention to it.
Yeah.
Thank you. My question is concerning the nature of your data. Is this native language data? These are people writing in their native language? What's the quality of the essays?
As I said, we crawled this data from an online forum, and I think it's not native data. But however, for providing support for students, we have also to recognize those argumentation structures in, let's say, some kind of flawed data. So the method should be not only able to identify perfectly written arguments, because I assume this is similar to the legal domain where we have really standardized argumentation structures and well-formatted argumentation structures. So I think it's easier in perfectly written texts, and for providing feedback we need really some, let's say, some flawed arguments which also might include fallacies and so on. So we carefully selected the data source because of that issues. So since the method should be also able to identify yeah, as I said, flawed argumentation and in bad texts, actually. Right.
So a related question, it's been claimed that the argumentation structure in essays is different in the United States than, say, in France or Germany. In the United States, you have the claim up front and then an argument to support it. In France, you'd more likely have the topic up front, an argument, and then the claim only at the bottom. First of all, are these texts from an American context? And secondly, have you looked at this, and would this affect your performance?
So your first question is in the direction of the annotation scheme, right? If I understood that correctly. So there are indeed several approaches for modeling arguments, and we also investigated a lot of argumentation theories. And we actually selected a very simple approach of modeling the argumentation structure, and which is based on several theories. For example, we followed the theory from Freeman and Dammer for setting up this annotation scheme. And with respect to your second question, we have not compared that to between different language. I guess that was your question, right? No, we have not done that. But we have currently a group of 5 researchers in the argumentation domain at our lab, and there are other guys in our lab who also investigate argumentation structures with similar schemes, for example, in German texts and German scientific articles, and this work is also ongoing currently.
Okay, thanks. Let's thank again our speaker.